Okay. So today, we're going to still do some things in review, but once again, it's just so that we're getting back into that mathematical sense. If I threw stuff right at you, not necessarily the first one isn't something you can do, but it's just getting good with your math sense again, right? Because it's been a while. So, really quickly, okay, we factored yesterday, right? That was our whole goal, was just factoring. Most of them were quadratics. This is not a quadratic. It kind of has similarities of a quadratic trinomial, but it wasn't quadratic, right? That is a quartic, correct? Okay, and we could actually solve that quartic, and we'll be doing that later this unit. But at the same time, what other ways can we solve using quadratics besides factoring? Quadratic formula. Let's write that down really quick. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And some people are like, what? You can sing to it? There's like another song, but I don't like that one. Okay? Now we all get to sing. And if you don't want to sing with me, I will call on you to sing later. So sing with me. Terrible. They would, if it's an equation. Now, I can't just do like what we did yesterday. None of those I could solve at all because I can make them look different, but I can't solve them because there's not an equal sign. This is when we're actually solving equations of quadratics. Does that answer your question, Mike? Everybody with that? That's a good question. This can only happen when it's equal to something, right? Equal to 0 or 4. Okay, here we go. In tune of pop those. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So, me personally, even when I plug stuff in, I see it. Okay? I can still remember my 11th grade dressed up in the did. I still can picture it right now. I don't even remember her name, but I can still picture her in her weasel suit. Okay? They don't make weasel suits my size. With that being said, what's another way? We said quadratic formula. What's another way? Anyone? How about completing the square? Okay, completing the square is a way to do it. On a 1 to 10 scale, I want to say, no, because I hate it. But I'll still do it. Now, I will personally, only Mr. Roberts, me personally, I will only do it in certain cases. The case has to be that my A value is always 1. Meaning my mean coefficient is 1. Other than that, I don't want to. Unless I'm in circles, ellipses, or hyperbolas. And then I have to. Okay? Does that make sense to everybody? I'm going to hurry and show you that. Now, once again, it's been a while, so I just want to see if you guys can remember the pattern. So, here we go. You 3 rows, you guys are going to break these guys down. You 3 rows, you guys are going to work these guys. Okay, by the way, is this guy right here x squared plus 9? Because remember, you can't just bring in a squared, which a lot of kids want to do. Remember, what is this equivalent to? X minus 3 times, and then I will distribute it through, correct? Okay, I'm going to push pause. You guys are going to go ahead and take that time to do it on your own. Really. You should really look at another period. There we go. There we go. So, thank you, though. But you're all in here, so you should feel good, right? Okay, here we go. What fills the blank? That would make this a perfect square triangle. Don't shout it out. I want to see if people can understand it. Because sometimes when we shout out the answers, what does that all of a sudden do? It makes other people's brains stop thinking. Because they don't have to think anymore because somebody's already responded. Does that make sense? So sometimes I would like you to hold your answers until I call on somebody, just so that we can always make sure everybody has that right and that opportunity to think about what they believe it is. Does that make sense? I know sometimes I was the kid that was the, that was me. Okay. Go ahead, sir. Help me your name. You raise your hand. Ethan. Ethan. You're going to be, I'm going to remember you because you're my nephew. Hi, nephew. I have a nephew. Go, Ethan. Why? Well, because if we went here, because once again, if the binomial squared would look like this, correct? Because we would have to double to get to him, right? Squared to get to here. So if I started here, I have to cut the middle term in half to figure out what this guy is, right? Now, once again, is that the case on all of them? What if this was a 2? Is that the case? No. But, like I said, I really only want to do completing the square when my A value is 1. Okay, because that's other than that, y. Okay, so once again, to fill the blank, cut him in half, it was 7. Then I'm going to take that number and square it, as you said, right, Ethan? Which is 49. Okay? Everybody there with me? Does anybody want to know? Does everybody know how the quadratic formula came about? Came through, completing the square. You get the opportunity to see it. Now we're going to get on. How many of you guys have seen it come through? Has your teachers ever showed you how the quadratic formula came through? You might have. Here's our most generic quadratic equation you could have. Is that a correct? Is that the most generic that you could have? Because I don't know what the A value is, the B value, or the C, do I? So would this work for any quadratic equation? It would, wouldn't it? Okay. So, hence, where the quadratic formula can work for any quadratic equation has to be something we can do every time. And completing the square is something I can do every single time. Is it always a favorite? Okay. So like I said, I always like to have my value in front of x squared or the A value there to be 1. How do I get rid of A? I'm going to divide it out. So I have, you guys don't have to write this down, by the way. Just observe. Just really just observe. Plus right? Is this a perfect square trinomial right now? No. Because remember, what did we just do with Ethan? Ethan took that middle term and cut it in half, didn't you? What's half of B over A? B over 2A. Right? And then I square it. That should be here, which should be B squared minus over 4A squared. Is that what it is? No, so I don't like it. So I'm going to go ahead and get rid of this guy really quick. All I did is subtract him to the other side. I'm okay to do that, can I? As long as I do it to both sides? Yeah. If I subtract CA from CA, that's 0, hence the blank. Okay. Yeah? Okay, once again, to complete the square, cut him in half. That's B over 2A. Then, as we did with you, I cut the 14 in half to make it 7. I took that 7 and then I squared it. So I need to cut the B over 2A, that's the half, and I square it. That's the B squared over 4A squared. But can I just all of a sudden throw something into an equation? Mm-hmm. I need to balance it, don't I? So I need to add, right? Okay, this is now a perfect square trinomial. Cut him in half, it's B over 2A. If I square it, that's B squared over 4A squared. Oh, it's a perfect square trinomial. So I can go into my binomial square. Now, once again, do I care if you know how to do this? Just to give you the idea of mathematicians aren't just saying, bam, here's the formula. Yeah. Learn it and love it. Okay? But there's a reasoning where it came from, right? Hey, what about this side? We need a common denominator. Think of Arnold. I need a 4A. Oh my goodness, what's on top? Getting there. Looks a little familiar, doesn't it? Is it all the way there yet, though? I'm not used to that 4A squared, huh? Okay, how do I get rid of this squared right here? Square root. And when I take a square root, what do I need to do? Plus or minus is what a lot of people forget when you take a square root, right? Remember when you physically take the square root, when you're putting it on the paper, okay, meaning it wasn't there before, you need to do a plus or minus, right? A lot of people forget that. So I need to do plus or minus. Okay, so this guy's x plus b over, oh, this should be 2a. I apologize. That was the half mark, wasn't it? Okay, apologize about that. Equals plus or minus square root of b squared minus 4ac all over the square root of 4 is 2. Square root of a squared is a. Is x by himself yet? No. So therefore x equals negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. And because they have a common denominator, what happens? I can just add the top. That's where it comes from. Okay? So, once again, it's not, oh, is it raining? Yeah. Yes, people, yes! Rain some more! No. Sniffles? Okay, so, hey, just remember, replacing good too. We're going to solve it. Okay, it's easy. No, machines are of the devil. If you don't have to use them, don't. Say no. Because on your calculator, on your test, guys, there's times I take your calculator away from you. I say no. These questions are no calculator. Okay? So you got to be aware. Some kids rely upon their calculators a little too much. Okay, I would like you guys to complete this. Ah, fricker frackers. Sons of biscuits. We're going to erase this 12. It's okay. Let's make him a 15. And the reason being, oh, fricker frackers. Let's make him a 16. Just for, fricker frackers. What the heck, people? I've done this all day today and I haven't had to do this. Okay, let's make him, no, not 9. Let's make him an 8. Sure, that'll work. I promise it's going to work this time. That was horrible. I'm so sorry. Okay. We are going to solve by completing the square. Okay. Is this a perfect square trinomial? No. It is not. So I need to make it a perfect square trinomial. What should be there instead of that ugly 8 in the outside? I want that to be a 16, don't I? Why do I want him to be a 16? Because cut him in half, which is 4, and then I should square him, and I should have that number to make him a perfect square trinomial. I am wanting that to be a 16. And it's not. It's an 8. How do I make an 8 become a 16? I could add 8. But if I do it to one side, I got to do it to the other. Right? Am I a perfect squared trinomial now? Yeah. Yes. Half of 8 is 4. 4 squared is 16. So I made it that, right? Just by the way, some of your other teachers might have just did this. I'm going to just show you the other way. I usually taught my students this method, meaning, oh, I subtracted that 8 over. He wasn't perfect. So I want him on the other side. So what fills the blank? 0. No, what fills the blank? 16. So if I add 16 to this side, what do I got to do this side? Add 16, which still gives me my, gives you the same way, right? Does that make sense? Okay. So we're here. This is us. Okay, what is this equivalent to? The whole reason why we just did it? 4 all squared. I didn't hear your X. I only heard the 4 part. Because remember, that's the whole reason why we did this perfect square trinomial. Is because remember, if it is in that fashion, I can go back and forth, like with our examples that I had you guys do, right? They're equivalent. And if you can see that pattern, you can quickly transition. With me? Okay. So, that is correct. X plus 4 squared does equal the thing above, right? Reese, you on it? We okay? Okay. And now we made it into this, so we can go a little bit further. Take the square root. But once again, when I take the square root, what do I need to do? Plus or minus. So I'm at x plus 4 equals plus or minus root 8. But I don't like root 8. Because I need to go ahead and break him down. 2 and 4. 2 and 2. So hence, buddies. I always talk about buddies getting out of jail. Mrs. Merkley. Who had Mrs. Merkley? Anyone? One good shot. Or something like that. Because when you get out of jail, somebody's got to sacrifice. Hopefully. Okay. All right. So I have x plus 4 equals plus or minus 2 root 2. Am I done? Is x by himself? What do I need to do? Subtract the 4. There should be. Okay. That was solving by completing the square. Now we're going to use the exact same equation, but solved by the quadratic form, and see if we get the same result. Okay. Everybody with me? Was it x squared plus 8x plus 8?
Yeah.
Everybody there with me? Okay. What's my a value?
1.
Okay. Who's my b value? And my b value is this guy, by the way, just because we have 2 where the b value is. Who's my c value? That was warm air. That sucked. I really could use a nice cold pool. I could, but I won't. I got stuff to do. Here we go. Even as I plug and chug, my friends, because that's what we're going to do whenever you have a formula, it's plug and chug. A monkey can plug and chug. Still in blue, it works. Okay. Just for people that can't see. Just. Okay, so this is 64 minus 32 in there. Right? 32. So in the end, it will be 32. So I have x equals 8, negative 8, plus or minus square root of 32 all over 2. Is that the same? It is, in a way. Just not simplified, right? Because how can I break down 32? What's in 32? Okay, 8 and 4, which you just said is 2 and 4. Look, buddy. One gets shot. Is that the same answer? Because we can continue to Reduce, because boom, boom, boom. What do those guys all have in common? Hence, negative 4 plus or minus 2 root 2, which is the same result as I had, right? Right. Any questions there?
No.
I hold if you need me to hold. Ooh, Betsy, that's all you gotta say. Betsy was my horse. She died. She ate too many apples. Then she foundered. And we're like, oh, you can't keep a foundered horse. Dog food. Might as well get some money out of that. Some people bury their animals. We get money out of it. I don't know that. We can Google it. You got your phone. Hey, speaking of which, somebody told me about this. I don't know if it really works. Has anybody did pocket points? A free what? There you go. You just sign it on your phone, and then you do something like turn it off somehow, and you put it for your allotted time to use your phone. Look, I won't be on my phone for a half hour. If she doesn't be on her phone, she gets points, and the more points you get, there's more gift cards. Just to let you know. I don't know. I don't know exactly how it works, but supposedly she's pretty into it. She's got a couple of them.
But
Religious studies, guys, don't tell. It's easy. Okay. What is it? Yes. And then they die. Well, and so they're hurting, so we kill them. I know, people don't. I usually don't get too into detail. I see animals different than you guys see animals. I see animals as they're tasty. I've been told, like my cousin's daughter just went. She went down to Chile and they eat her. Like, you should eat her more often. That's what she said. She liked it better than their hamburger. When I was in Mexico on my cruise, we were in Mazatlan, and the guy, the tour guide's like, "You guys mind if I take you to really what Mazatlan is?" And he took us down to a downtown market. It was really cool. It was like on this big old table. Anyway, sorry, math. Yes, yes. I do get off topic because I can't do. I understand, guys. I can't do math for freaking an hour and a half. I don't know how. Yeah. Anyway. Sometimes I've been told it looks better when I don't. I don't mind. I'm just joking. Okay. Can I factor? No. Well, yes in a way and no in a way. Yes, I could factor, but it's not a way that you guys know, really. And B, this is not a difference of squares. This is a sum of squares, right? So a difference of squares, they factor with imaginary. But I don't have to, because all I got to do is solve. And anytime I don't have an x term, a linear term, I can just subtract him over, can't I? Now, when I look at this, though, x squared equals negative 4. Okay? X squared equals negative 4. What makes this a non-real solution? Go ahead, Hallie, since she rose her hand. Okay, square root, okay, awesome, that's great. That is all true and all. Don't get me wrong. I'm getting I want a little deeper. Anybody else? What's telling me right there? Boom! That it's imaginary, not a real solution. I'm not changing from that. You went with the square root, which is true. I just want to go from square root. Staring right at us in our face. The negative, what does that matter? I've had negative solutions in the past. There's something that up there is making it matter. Okay, go ahead, sir, over on the side. Boom. Right there, as he just said. It's something squared, and that something's what I'm looking for, correct? X is what I'm looking for. And when... What the heck was that? Was that that? Or I thought he was just doing his neck. I thought, oh. I almost struggled. I'm like, whoa, that was bad. Oh. I only heard that, and your neck was moving. It was, oh. Okay. When I square something, it cannot be negative. That makes it imaginary, because anytime I square something, it should be positive, right? Hence, there's no real solution, but there are imaginary solutions. And I really wish they wouldn't have called it imaginary solutions, because they are still useful. Every time I say imaginary solutions, then why do we do them? Right? But they are still important. A lot of our mathematics comes from imaginary solutions. They're there. Okay, once again, we take the square root, just as you were saying, right? And when we take the square root, we do plus or minus. And then I get plus or minus 2i. I had a question earlier. They said, Mr. Roberts, I thought imaginary solutions were negative, square root of negative 1. That's not square root of negative 1, that's square root of negative 4. Why? How can I still adjust that to make it work?
And like out of the service, you just have like it's kind of you just have to record the next one.
Because whenever I have square roots, as long as they're underneath the same radical, square roots where I can find them. Does that make sense, everybody? So isn't 4 times negative 1 negative 4? What's the square root of 4? 2. What's the square root of negative 1? I. Hence why anytime I have a negative number, it's always going to be I, right? Because I can always pull out that. Okay. There we go. Very simple. Now, when I do my quadratic formula, or even when I do my completing the square, could I come up? Definitely. Okay. Just want to make sure. Awesome. Okay. Really quickly. Once again, this should be review, should be something in your head, just sweeping out some cobwebs, right? Not been for a while. You've seen that before, haven't you? Yeah. You look like I Dream of Jeannie. You know what that is? Google it if not. Okay. Google. My wife always asks me questions. Why do you think this? I'm like, we have Google nowadays. Why are you asking me this? Ask them. Okay. So, what does that mean? Page a little bit. I'll work on it. How many solutions? Whoa. Technically 1. 2 solutions, right? 2 real solutions. How many solutions? 1 real solution, but what we also say is 1 real solution with multiplicity of 2. Which you might not know what the word multiplicity means. We'll get a little bit deeper in that. But at the same time, it means, hey, like, for example, let's say I'm doing the quadratic formula. How many times have you guys seen this? What is the square root of 0? So I have 4 plus 0 over 2 and 4 minus 0 over 2. Even though it gives me the same result, it took 2 ways to get there. I did the 4 plus and the 4 minus. So it's still the same solution. 1 solution, but it's the 0 happening twice. Meaning it gave me from this guy and this guy. Does that make sense? So how many solutions did we really have? Yes, 1 is there, but it's still 2 solutions. Okay? That's where the fundamental theorem of algebra comes in. Notice on this one right here, m to the 4th. How many solutions should I have? 4, because the highest power is 4. If I had x to the 100th, I should have 100 solutions. Now, some of those solutions might be the exact same solution, just multiple times. Does that make sense what I'm trying to do out there? So it's still 2 solutions, but 1 real solution with a multiplicity. You guys don't have to worry about that right now, but I just want to talk about it. What about this? 0 real solutions, but 2 imaginary. We will always have 2. Always 2 solutions on here, 4 solutions. On number 4 in the bell quiz, 3 solutions. Okay. Because, do we cross the real x-axis? No. That's why still every solution, there's always solutions to any quadratic. If you don't cross the x-axis, it's not real solution. Okay. Are we all good with that? That's just something that's on the homework. Okay, then we're going to get on to factoring, because we did that one already. So, give me a number. Help me name again. Connor. Give me a number. 7. We did this already. It sucked. Okay. Yeah, Remington. Did I have you in driver's ed? Oh, okay. Kelsey, give me a number. Be respectful. Oh, okay. I had to think in my head, okay. Just a little bit. Oh. 98. Yeah. Now I gotta think of what I want in the middle. Okay, we'll make it easy. Okay, here we go. So we're gonna set that equal to 0 and solve it. So what we're gonna do is go 7 times -14, which is -98. Factors of 98 to give me 97. Look how nice that was. Nice stuff. So look, 7x squared minus 98x plus x minus 14 equals 0. Did I do it wrong? I mess up. I understand I mess up. What do these guys share? 7x. I'm left with x minus 14. What do these guys share? 1. Don't always say nothing, because they always have a 1. Always have a 1, right? Everybody has a 1 in common. So then I get to how does a binomial, two of them, when they're multiplied, because there's a binomial times a binomial, this is a binomial times a binomial, equals 0. When one of them or the other is equal to 0. Because they're not necessarily always going to be 0 at the same time, are they? Huh? They could be, but not always, right? What value makes him 0? Well, I'm going to find out by setting him equal to 0. Because when I set him equal to 0, that tells me when it would be 0. 14. What value makes this guy 0? Subtract him over. Those are the two places that makes that original equation equal 0. Okay? Try for 2 of these today. He tries on 20 of those a day. All right. Pretty self-explanatory, pretty easy, right?
Yeah.
Okay. Last example of the day. So now we're going to go backwards. I'm going to give you solutions. Now we're going to write the formulas of the equation. So basically, we're doing our last problem backwards, right? You're starting exactly what they give you. They give you the zeros or the values that make it 0. Please find. Now, really quickly, do you guys know there's an infinite amount of solutions to this? I could have an infinite amount of answers.
Yeah.
Why? Let me explain. So let's imagine this is my shoulders, okay, are where it's crossing the x-axis. Here is -4, here is 3/2, right? Here we go, there it is. There it is. There it is. There it is. Still, my shoulders haven't moved, have they?
No.
Still the same zeros, but I'm getting different problems. There it is. Right? There it is. There it is. There's an infinite amount. Okay, that makes sense because there's a lot of equations that can go through the same 2 points. There's only one equation at a time. Does that make sense to everybody what I'm going for there? Okay, so as we look at the previous example though, we want to go from this step to this step to this step and so on. Right? We're going to go from here to here to here to here. With me? Okay. So we're going to make this equal 0. How do I get this to 0? I could just subtract him over, but anytime I see a rational function here that's improper fraction or reduced fraction, because not integer, but rational, I want you to times him over first. So it's going to be 2x equals 3. And then where that 3 is, what do I want right there? I want a 0, so how do I make him a 0? Subtract it. Okay. Add 4, right? Look, there's my 2 binomials. That made me 0, right? So this was 2x minus 3 times x plus 4. Those binomials, if I times them together, would give me 0, but it'd be these values. But is that simplified all the way? Just one more. So I'm going to say 2x squared plus 8x minus 3x minus 12. That is one of infinite solutions that there can be. Make sense? I think I need to use 2 more.
I'm just gonna get a lot and then it goes back next year over to them.
Okay. Guys feel good?
Yeah.
Okay. Once again, if you guys need help, come and visit me. More than welcome.